So now we're going to look at graphs at rather odd-looking functions like x to the 2/5. And again, we'll use our first derivative and our second derivative to make this graph. First, let's realize when looking at this, we need to consider the domain. We can square any real number, so that doesn't change anything, and we can take a fifth root of any real number. So the domain of this function is all real numbers, and that's good. We don't have to worry about any domain restrictions. However, if this bottom number had been an even number, we would have had to worry about, we can't take a even root of a negative or of 0. So that changes our domain to anything greater than 0. So watch for that in these sort of problems. If this bottom number is even, then we're looking at only 0 to infinity for our domain, or really not including 0, so anything greater than 0. Okay, so let's take our first derivative and get increasing and decreasing and maxes and mins. So in this instance, we'll do our first derivative. It is just using the general power rule. So we'll have 2/5 times the front. Lower that exponent by 1, and we get negative 3/5. All right, now don't let the fact that that is a negative exponent bother you. The only place where this is 0, or really the denominator, since this is this really goes into the denominator, is 0, is where x is 0. It's our only value. So let's put that on a sign chart. If we choose something over here, let's say a 1, or I'm sorry, negative 1 is over here, not 1. If we raise negative 1 to the negative 3/5 power, and you can put this in your calculator if you have difficulty thinking about that, we will get a negative 1. And if we multiply it times 2/5, that'll still be a negative answer, so this is negative over here. If I choose something on this side, let's say positive 1, if I raise 1 to the negative 3/5 power, again, if you have trouble with that, put it into your calculator, I will get a positive answer. Multiply it times 2/5, that is positive. Do not get into the wrong thinking of thinking that a negative power makes a negative answer. That is not the case. A negative power puts things into the denominator of the fraction. So just be careful about that. So this is positive over here. So from this first derivative, we get from negative infinity to 0. This is a decreasing graph. And from 0 to infinity, this is an increasing graph. So decreasing and then increasing, this is a minimum. And remember, we said up here that nothing was undefined for this original function, so we can plug that 0 into the original function and actually get that minimum, which is just going to give us 0, because of course 0 to any power is going to be 0. That's our minimum. All right, so there's the first derivative. Let's do our second derivative. All right, so we'll just go straight from this one right here. We will take negative 3/5 and multiply it times 2/5, and that's negative 6 over 25. Lower this exponent by 1, subtract 5 over 5, we get negative 8/5. And again, if we set this to 0, only x equals 0 is a critical value. So let's put that on our number line. If we choose something to the left of 0, let's say negative 1, well, because of this 8th power here, remember the negative would only stick this in the denominator. negative 1 to the negative 8 over 5 is going to end up being positive. And then we multiply it times this negative out front, it's going to give us a negative. Again, if you have trouble with your signs here, just put negative 1 raised to the negative 8/5 into your calculator. Just be sure when you raise it to the negative 8/5 to put this whole thing in parentheses, or you will get the wrong answer. All right, now let's choose something over here. Let's say 1. Well, same thing. When I raise 1 to the negative 8/5, it's going to be positive. And when I multiply it times this negative out front, it's going to be negative again. So this thing is always concave down, but let's be careful. Do not write this as negative infinity to 0, that it's concave down, because it's not concave down directly at 0. So negative infinity to 0, and then 0 to infinity, it's concave down. And 0 is not an inflection point because the signs do not change here. We also already have the y value for 0. We got that right up here when we were finding the min. All right, so we have 1.00. We're going to graph this thing from that 1 point. So I got 0, 0. We're going to use our increasing and decreasing and our concavity to help us here. So this graph is decreasing until it gets to 0, and it's concave down. Only one way to draw a decreasing concave down graph. That's to do like this. All right, now, after 0, the graph is increasing, and it's still concave down. Only one way to do that. Increasing concave down is like this. So our graph sort of looks like a bird flying, and a lot of these will. We'll see kind of a bird shape.